Hi, welcome to today's video. Today we're going to talk about relations and functions. So before we do that, let's talk about a little bit of vocabulary. First of all, a relation could be one of two things. It could be just a set of points. And so here is an example of a relation, just a set of points. And it could also be an equation. So for example, y equals 2x or x squared plus y squared equals 9. Both of these equations represent relations. Okay, so a function is just a relation where there is exactly one output for every input. So our input values can only be used one time. We can't have multiple input values that are the same. Okay, the domain is a set of all of the input values, usually the x values, of a relation, and this is also known as the independent variable. And the range is just the set of all of the output values. So domain was input, range is outputs. It's usually the y values for the outputs of a relation. And this is also known as the dependent variable. And in just a minute, we're going to see some mapping diagrams. And a mapping diagram is a diagram that links elements in the domain to elements in the range. Okay, so first off, for our first example, determine if each relation is a function. So let's take a look here. We have a set of points, 1, 2, 2, 3, 3, 4, and 3, 5. Well, notice here, since we have 3, the value, x value of 3 goes to 4 and 5. So because we have these repeated x values, this is not a function. So since the input value of 3 has two different output values, this is not a function. Okay, so let's look at the next one. Negative 1, 5, negative 2, negative 3, 0, 6, and 1, negative 1. Again, just a set of points. So we have to look. And since there are no repeating x values, or no repeating input values, this particular one is a function. Okay, so next example. Notice here we have some mapping diagrams now. We have our domain, which is the x's. We have our range, which is the y's. And we show a mapping from a number in the domain to a number in the range. So here, if we wanted, we could list those points. This represents a point 5, negative 1, 4, negative 3, 3, negative 2, 2, negative 5, and 1, negative 4. So we have a set of points just like up above. So what we have to look for, do we have any x's that are repeating? Well, notice we don't have any repeated x values. So each input maps to exactly one output value. So this particular one is a function. Okay, next one, another mapping diagram. We have negative 2, 1, 2, 5, negative 4, 2, 4, 3, and 0, 5. Well, again, since we don't have any multiple x values or any x values that are repeating, this particular one is a function. Each input value maps to exactly one output value. Now notice here, we do have 5 in the y values that are repeating, but that's okay to have. This does not cause it to not be a function. So repeated y is okay, but a repeated x we can't have. Okay, so let's look at example C. We have negative 2 goes to 0, negative 1 goes to 0 and 2, 0 goes to 4, 1 goes to 2 and 4, and 2 goes to 6. We'll notice here, since negative 1 and 1 both go to multiple values, this particular one is not a function because of that. Okay, so the next thing we'll talk about is if we have a graph, it might be kind of nice to have a way that we can use to test to see if a graph is that of a function. So we do have a test for that. It's called the vertical line test, and you might remember this test from Algebra 1. The vertical line test is just a test that we can use to determine if the graph of a relation is a function. If a vertical line goes through the graph at more than one point, it is not a function. Okay, so in example 3, we're going to use the vertical line test to determine if each graph is a function. So if we look at A here, well, if we put a vertical line over here, notice it only goes through the graph at one point. So we're okay over here. But what happens when we come over here, say right on the y-axis? Notice it goes through the graph more than one time. In fact, it goes through the graph 3 times altogether. So because this is going through the graph, this vertical line is going through the graph more than one time, this one is not a function. So not a function. Okay, so let's look at B. We'll notice B here, if we take any vertical line, and I'll put in a few here. Notice that any of those vertical lines, and we could go anywhere on there, and it would only go through the graph one time for each vertical line. So because of that, this one is a function. Is a function. Okay, so let's look at C now. So if we test C right on the y-axis, notice it is only touching the graph at one point, right there at the origin. So if we just do one test, we're okay, but we have to test it at every place along the x-axis for our vertical lines. So if we move over here more to the right, notice this particular vertical line goes through the graph in 2 different places. So since we're going through the graph more than once for this vertical line, this is not a function. Okay, and last one, hopefully in D you can kind of tell no matter where we make our vertical line, it will only go through the graph one time. So in D we do have a function. Okay, so moving on. So now we're going to look at domain and range a little bit closer. So finding domain and range. Remember that the domain is the set of all of the input, or x values, and range is the set of all of the output, or y values. So in example 4, what we're going to do is we're just going to find the domain and range for each of these functions. So, or relation. So find the domain and range of each relation / function below. So here we have a relation. Notice it is not a function because I have a repeating x value here. So in this relation, what is the domain? Well, remember the domain is all of the x values. So we look at all of the x values. We have a 1, we have a 2, we have a 3, and we have a 4. So I've listed all of the x values out. Notice I didn't put 2 twice. We don't have to, if a number repeats, we don't have to put it more than once. So to show that, we say x is an element. The little e there means it's an element of the set of numbers 1, 2, 3, and 4. So for sets of points, always just use the set brackets to show that set of points. Okay, so in the range, y is an element of, well, we have -1, -2, -3, and -4. So y is an element of the set of points -1, -2, -3, -4. Okay, next example. Y is equal to x plus 5. So maybe it might help to graph that. So I've made a graph of y equals x plus 5 here. And notice that we can continue on in that direction. And even though the graph stopped here, it can continue on in that direction. So for our domain, we can put in any value for x. It's okay. There is nothing stopping us from putting in any value for x. So several ways we can write this, and depending on what book or what website you might happen to look at, they might show it in different ways. So I'm showing you multiple ways that you could represent this here. We could say x is an element of the real numbers, because remember we can put in any real number here. Or the next way of showing it is we could say x such that -infinity is less than x is less than +infinity. So we're saying really any number we could put in here, but here would be the way that you would show that. Or, and that is called inequality notation, by the way. And we could also use what is called interval notation. And so we would say x is an element of the numbers within the interval of -infinity to +infinity. And notice the soft brackets here. I'll show you, or parentheses, I'll show you another symbol that we might use there in just a second. Okay, and for our range, well, our y values, if we put in some x value, we can put in any x value and we will always get some other y value out. And really, we can get any number back out of this. So our range is y is an element of the real numbers, or we could show it as just like up above, y such that negative infinity is less than x is less than positive infinity, or using interval notation, y is an element of negative infinity to infinity. Okay, a couple more examples here. Okay, example C, y equals the absolute value of x. So I've made a graph of that here. Notice the V shape of this graph. So for our y values, notice we can't have a y value in the negative range, and hopefully that makes sense. If we put in some negative number for x, the absolute value is going to make it positive. So we're never going to get a negative number out of this function. So it's going to affect the range a little bit. So, but notice we can put in any value for x, so we're not restricted there. So just like before, x is an element of the real numbers, or x such that negative infinity is less than x is less than infinity, or x is an element of negative infinity to infinity. Okay, but now for the range. The range has to be some number bigger than 0 or equal to 0, is if we put in 0 for x, we get out 0 for y. So we don't really have this type of notation for that, so I'm just going to jump to this. So we have y such that y is greater than or equal to 0. So just write an inequality for that. Or y is an element of 0 to infinity. And notice I included a hard bracket here instead of a parentheses. The hard bracket means we're including the endpoint. So it's like that because we're including the endpoint. And the soft bracket means we don't include the endpoint. So you might be asking, well, why are we not having a hard bracket here? Well, because infinity really is not a place that we can get to. It continues on and on. So it's not really a set actual number. So we have to include a soft bracket on this side. Okay, so our final example. Notice I have two parts to our graph here. In this one, we have this piece over here and we have this piece over here. So it's kind of split. So for the domain, the x values, we'll notice the arrow, so it continues off in that way in the x direction, and it does continue off this way in the x direction as well. So we just have to look at our endpoints. So we're smaller than -4, but we can also include -4 because that dot is filled in. And this one is not filled in, so we're going to be bigger than 2, but we can't be equal to 2. So to write out our domain, the set of numbers x such that x is less than or equal to -4, or x is greater than 2. And here's how we would write that in interval notation. X is an element of negative infinity to 4. And remember, since that was filled in, we can include that point. So it's a hard bracket. In union with, that's what the U means, is in union with 2 to infinity. And notice, since we have an open dot here, I'm including a parentheses or a soft bracket here. Okay, so for our range, well, in the y direction, we're bigger than 1, and we could be equal to 1, or we're smaller than -3. So our range is y such that y is less than -3, or y is greater than or equal to +1, or here's how we would write it in interval notation. Y is an element of negative infinity to -3. Again, parentheses or soft bracket at -3 because it's an open dot. In union with 1 to infinity, I put a hard bracket around the 1 because it's included. So we are including that endpoint in our solution. Okay, well that's all we have for today. I hope you enjoyed the video, and I'll see you again soon.